My name is Mark Paganini from the European Space Agency. I'm a senior scientist and essentially on environmental governance and sustainable development, and I'm the technical officer for the World Water Project. So yeah, I should start from the water crisis because we know very well that water is key to sustainable development. It's important for socioeconomic activities, for energy and food production, for healthy ecosystems. And if you look at the 2030 Agenda on Sustainable Development, there is a dedicated Sustainable Development Goals on water and sanitation for the sustainable management of water, leaving no country behind. And it's really centered in the 2030 Agenda on Sustainable Development. Actually, I would say that water is actually present in almost every Sustainable Development Goals on the 2030 Agenda. But water is key, but water is also a crisis. There is a significant water crisis due to many aspects. In large part, it's due to the withdrawals of waters for various applications, for various use, I should say, like the socioeconomical development, but related in large part to the growth in population, but also to the growth in the socioeconomic development, and it's all exacerbated by climate change, which reduce the availability of water. When we did the project, when we designed the projects, we wanted to respond to these needs for better management of water and supporting essentially countries, and to a certain extent as well the basin authorities that manage transboundary water resources, in order to integrate Earth observations into their systems and their processes. And we did it in two ways. In one way, it was very important to develop a solution, but a robust and cost-effective solution that can be used by countries. Robust in the sense that it has to be scientifically robust, so we need to really exploit the satellite data that are available in a way that they can be used and provide robust solutions for countries. But the most challenging part in the projects was actually to engage these countries and ensure that what we develop in the project is fully integrated into their systems and into their processes. So empowering the countries was a key objective of the projects, and for this we conducted a lot of first, we involved them from the very start of the projects in co-designing the solutions with the team. So we engaged a number of countries as a sort of, we call them early adopters, where they were apart from the projects at the very start, and they helped us designing the proof of concept. And then in the second phase, we engage other type of countries in order to have a full spectrum of countries representing different type of issues in terms of monitoring the water resources. So, we wanted to have countries in tropical zones, countries in more dry lands or in high latitude. So we had a sort of a nice, let's say, set of countries with whom we have been working, and we engaged them actively in the projects in different ways. So we organized a lot of what we call Living Lab. It was a very nice name that we invented in these projects, which is nothing else than a participatory type of workshop where we involved them actively into discussions. The first objective was to develop the robust and cost-effective solutions, but the second, which is probably the most important objective of this project, is to transfer this technology within the user communities that we have engaged on these projects, which are essentially the national governments in charge for water resources in their countries, as well as when we talk about transboundary river basins, the regional authorities in charge of these transboundary basins. So what we did is to engage them in the projects from the very start. And for this, so we wanted to have a sort of co-design approach. And for this, we engaged what we call the early adopters. So we had 5 countries engaged from the very start of the projects to help us co-designing the solution, but also having a sort of proof of concept that we could in a way present to other stakeholders that we engage in the second phase of the projects. And yeah, that was quite a major achievement. That was quite a challenge as well to engage so many early adopters or so many countries in these projects. But at the end, I think it has been really a success. This project was started about 4 years ago. So when you start a project, you have to acknowledge what is available at that time. So most of the products that were available on the dynamics, on mapping, let's say, on monitoring the extent of surface water, were essentially based on the Landsat data. So they were available at 30-meter spatial resolution. So one of the key objectives of the project was to move to a higher spatial resolution, so to 10 meters, and that's where we decided to exploit the full-time series of the Sentinel-1 and Sentinel-2 satellite sensors. Bringing the 2 sensors together was an innovative part of the project, and the reason why we wanted to do this is because we didn't want to be constrained by the limitations of the single sensors. So bringing, for example, to give you a very simple example, if you go in the tropical regions where there are permanent cloud coverage, it's very difficult to come with a good and robust solutions only based on optical data. And that's where radar data are really key. So we exploit the full-time series of Sentinel-1 and Sentinel-2 in order to map what we call the monthly occurrence of surface water. So that's a sort of base map that we created for 5 consecutive years. And from there, we derived a number of indicators that provide information on how the surface water is changing in extent. So basically making distinction between seasonal and permanent water. So looking at what is the maximum extent, what is the maximum extent in a year and how this is changing over time. Also in terms of seasonal and permanent water, how much the seasonal water is changing within the year. So we are looking actually at intra and interannual variations. And from there, we derive a number of what we call change indicators. And from there, we derive what we call statistics, different statistics that we produce at the level of the country or at the level of the river basins. There was another innovation that we brought into these projects is the integrations into the solutions of estimations of surface water levels that we could derive from radar altimetry. So basically providing the vertical dimension, which is quite important and can be used in lakes and reservoirs to estimate the change in water volumes. For example, the water storage in reservoirs, which is, as you can imagine, very important for water resource management, but also by integrating the water levels in hydrological modeling, there is a way to estimate also what is the changes in river discharge. So this was also a big innovations that we brought in these projects. So not looking at the changes in water extent, but also looking at the changes in water volume and river discharge. Yeah, at the end, I mean, there were 2 parts, let's say, in the way we did the work. One part was the productions of all these maps, indicators and statistics that I was explaining before. And that was the responsibility of the project team. So in total, we mapped quite a lot because we engaged 9 countries in this project. So we had very large areas. So in total, it was more than 6 million square kilometers that we had to map for 5 consecutive years. And this was done by two of the project partners. So starting with this monthly occurrence of surface water, and then with all the derived maps. So you can imagine that in total, just for the surface water extent, we had almost 150 type of maps that were produced in the different countries and river basins that we were handling in these projects. So that was a big part of that project. So maybe to give you also some other facts, we had about almost 1,000 Sentinel-2 tiles. So Sentinel-2 tiles is the size of 100 by 100 kilometers. I'm talking about just the spatial extent of these tiles, not the number of tiles we process, which is much higher. And we had, in terms of computing resources, we estimate the level of processing to about 40,000 processing hours, which is, as you can imagine, quite important. There was also, as I said, the integrations of radar altimetry to estimate the water level. And for this, in all the countries that we engage in these projects, we had a bit more than 350 lakes and about 1,200 virtual stations in rivers. Virtual stations means the points within the rivers where we do have measurements on surface water levels. So you see quite high numbers, and that was a big part of the project. And all these data, so these maps, these indicators, these statistics were provided to the countries that we engage in the projects in what we call a data analytics portal. So it's a sort of website that we developed to provide a number of visualization functionalities, but also data analytics functionalities with the possibility to derive statistics, which we tailored, let's say, for each of the countries we engage in these projects. So that was a way, let's say, to allow the countries to access the data in an easily way, and also, to take a bit ownership of the data that were produced by the team. But since one of the objectives of the projects was also to build capacities in the projects, we also organize a lot of meetings with these countries. So we visit them. We went to Mexico, we went to Colombia, we went to Zambia, just to give a few examples. So these were some of the countries that we engaged in this project. So there were a lot of training and workshop organized with them, but considering the situation, it was not always possible to visit all countries, so we organized a lot of webinars, a lot of online training courses. We invited them to the final meeting here in Ezrin as well. And so there's been a lot of efforts also put in the projects in order to make sure that at the end of the projects, the tools that we have developed will also be made available to them and can be used by them. So for this, what we did is that we put the processing systems on the cloud. So basically on the cloud systems where there are high computing and storage resources, but also an easy access to the satellite data. And we gave access to the countries to make use of these processing tools during the project. So we also train them not only to use the data, but also to make use of the processing systems that were developed during the project. Yeah, this is quite an important question, because very often when we do projects, there is no really follow-up actions on what we achieve in the projects, and the users that we engage in the projects are sometimes left alone and without any support to further use what we developed. So maybe I have to give you a bit of background on what we developed in terms of data processing and data analytics. So we actually in these projects developed two different processing chains. One is if I must say this, a sort of proprietary solution that we developed with one of the partners of this project called GeoVille, which is in a way also optimized from a processing perspective. So it brings a lot of advantages, but with having the disadvantage that this is proprietary, so you cannot really provide this at no cost to the users. But it's usually the processing system that is the most efficient in terms of computing cost, especially for large-scale type of processing, as we have been doing in this project. And then we have another processing chain that was developed by another partner of the project, DHI in Denmark, that we made available as open source. So it's available in open source repository like GitHub, but it's also has been integrated in a open platform called OpenEO. And this OpenEO platform is a platform that ESA is supporting, and you will see where I'm coming with this, that ESA is supporting and ensure a certain level of maintenance for the user community. And I must say that that platform is now made available on what is called the CDSE, which is this Copernicus data space ecosystem, which is in a way, if I can summarize it in simple word, a sort of cloud infrastructures that ESA together with the European Commission is making available to the community in order to have an easy access to the Sentinel data without having to download the data on their own resources. And having the workflow that we did in World Water available on the OpenEO platform that is on that CDSC platform allows a certain continuity of availability of these workflows for the community. Maybe a small anecdote about these two processing change. There was a point during the projects where we decided to do what we call a round-robin comparison of methods in order to make sure that what we are doing in these projects is really the state-of-the-art in terms of accuracy and robustness of the methods. So we open actually these comparisons of methods to other developers outside of the project. So, and it was quite interesting because we had almost 20 partners participating to this exercise, and there was also scientific publications. And the two algorithms that we selected, so the one from GeoVale and the one from DHI, were amongst the best ranked algorithm for in that comparisons. And this is important in two aspects. What it builds, of course, it shows that actually we have a very robust algorithm developed in these projects. And second, it helps also to build trust with all the stakeholders that we have engaged in this project. So we will maintain these two processing chains available. And I must say that there is already a certain continuity of what we are doing beyond the lifetime of the projects. What, for example, I give you an example, what we've been developed with GeoVale on this proprietary type of solution has now been transferred in another ESA program, which is called the Global Development Assistance, so the GDA program that we have together with international financial institutions that include the World Bank and the Asian Development Bank, and where anything related to mapping and monitoring of surface water in different World Bank and ADB projects have been done using that type of technology and using the processing system that I was presenting before. So these activities are really essential because they make sure that what we develop during the course of a project are still maintained and make available with all the necessary support that we need to provide to the countries in order for them to make use of these workflows, these processing pipelines for their own purposes. And there's an additional point that I should mention as well. The open source solution has been developed in a way that is fully interoperable with other infrastructures. So it follows the concept of data cubes. And in our project, actually, we had a few countries that were already equipped with this type of technology, and we will be providing also some support to these countries in order to integrate these workflows on their own infrastructures. But of course, for countries that don't have such infrastructures available, they can make use of the European assets like the CDSE, so the Copernicus Data Space Ecosystems that is funded by ESA and the European Commission.